Good morning, class. Today we are going to discuss, as I told you all, that wherever you are having doubt, as we are doing the revision work now, so wherever you are having doubt, you just let me know through email. Then I will be discussing those portions. Okay, so I have got this last week. So the terms related to interconversion of states of matter. Here, maybe you are having some problem. Uh, so that we are going to discuss today. Okay, first of all, let us discuss what is interconversion of states. So we know there are generally three states of matter: solid, liquid, and gas. These three states are there. Now if we apply heat, we can interchange the states. Okay, from solid state we can get the liquid state, from liquid state we can get the uh, gaseous state. Okay, again, if we take up the heat from gas, that means if we cool it down, so for the first one, solid to liquid, we need to heat it. From liquid to gas, if we want to get, then again we have to heat this. We have to heat the liquid, then we can get the gaseous form of it. And again, if we go back, that means if we want to get liquid from gas, then we need to cool it down. For liquid, from liquid to solid, if we want to get, then again we need to cool it down. That means we can see here, if we change the conditions, that means the conditions are heating or cooling. If we change the conditions, then from one state to another we can interconvert. Okay, so this process is called interconversion of states of matter. If we take an example of water is the liquid form and its solid form is ice and its gaseous form is water vapor. So these three states are there. From ice we can get water, from water we can get ice, again from water we can get water vapor, from water vapor we can get water again. So these three states of water can be interconvertible. Okay, and the process is called interconversion of states of matter. Now one by one we are going to discuss this. First of all, from solid state to liquid state. From solid state to liquid state. That means from ice to water, if we want to get, then we have to heat this. We know that we need to heat ice, or if we keep ice in open, then from surrounding it will absorb heat and it can convert to water. Okay, so this process is called, name of the process is melting. Okay, melting or fusion. So when a solid uh, changes to liquid form, then the process is called melting or fusion. Here we sometimes we need to heat this, or actually we need to heat this. When ice melts itself, then maybe from outside we are not heating this, but actually it's absorbing heat from outside. So heat is required for the process. Okay, and this is called melting or fusion. Now why this will happen, why this solid form changes to liquid, for this we need to see the structure of solid and liquid. See, in solid we know that the particles are closely packed. There are very less space in between them. There are very less intermolecular space in between them. And in liquid, this is solid. And in liquid, the particles are, there are much more gap between the particles, and they are bit scattered here and there like this. Okay, so this is liquid. Now what happens when we are heating the solid? When we are heating solid, the heat, heat is a kind of energy. So the heat is absorbed in all these particles of solid. Okay, the particles of solid or the molecules of solid, they will absorb heat and they will get heated, and because of this their energy, kinetic energy, will increase. Okay, as we know that all the particles, they they are not fixed, they are not they are moving. Okay, they are moving. So for solid, as the intermolecular force of attraction is highest in solid, so the particles itself, they cannot move as we get that for liquid and gases. But for solid, the particles will not change their place, but uh, being fixed at its own original space, they will vibrate. Like if we just I'm showing only one particle. Okay, so suppose this is one particle. So when it will get heated, it absorbs energy, it starts vibrating. Okay, so from its this position only it will vibrate. So from there only it will be there, but it will vibrate left and right side in this manner. Okay, so all the particles will vibrate in this manner, and they will push. Suppose this particle, one particle is there, and just beside this another particle is also there. So this particle is also absorbing. After absorption of energy, this particle will also vibrate in this manner. So all the particles will vibrate and they will push each other. Okay, so as more we are applying heat, as more the heat will be absorbed to the particles, the vibration will increase, and because of this vibration, the particles push each other and the gap between them will increase. Okay, it will increase continuously, and after some time we will see the gap between the particles will increase gradually. Okay, and after certain time we will see the particles will become in this manner. As in liquid form we are getting the particles, there are a lot of space between them. So in that manner we are going to get the particles of solid. Okay, so that time the solid state will convert to the liquid state. So what happens here, after as we are applying heat, the heat will be absorbed by the particles of solid. The particles will absorb the heat and they will start vibrating. Already they were vibrating, but the vibration will increase after absorbing heat, and they will, from their mean position, they will vibrate in this manner, and because of the vibration their intermolecular gap will increase, and after some time, because of this vibration, the intermolecular gap between them will increase in such a manner that the solid state changes to the liquid state. Okay, and then the structure of the solid changes to liquid, as lot of space will be there in between the particles. So in this manner, during the melting process, the solid particles, the gap between the solid particles increases, and the state of the matter becomes solid to liquid. Okay, so here we are getting another term, that is melting point. Melting point. For any particular state of change, any particular suppose if we take the example of ice to water, this conversion, then during this melting of ice we will see that the temperature of the whole system, or the temperature of the ice and water, it will become fixed. It will be fixed at a point, okay, at a temperature. The fixed temperature will be there. That temperature is called melting point. At normal atmospheric pressure, here we need to keep the pressure constant, because pressure is also having some effect on this melting point and this conversion. So here we need to keep the pressure constant. So at constant pressure, the melting point of ice, pure ice, will be 0 degree centigrade. That means during the process of melting of ice, the temperature remain constant at 0 degree centigrade. So 0 degree centigrade will be the fixed temperature for melting of ice. Okay. Why this temperature will remain fixed? As we are, you can see we are applying heat here. So heat generally it increases the temperature, but here during the change of the process we will see a constant temperature. Why? Because the heat which we are providing, that is helping the solid to change its state from solid to liquid. That means the temperature is absorbed in the particles of solid, and the particles increases their increase their intermolecular gap between them, and they become solid, they become liquid. Okay, so as the heat is engaging itself to do some other work, that means to change the state of the matter, so it will not going to increase the temperature. So the temperature will remain fixed. So suppose if we take some ice in a container, suppose in a beaker we have taken some ice. Okay, so these are the ice cubes. Suppose, okay, these are the ice cubes we can take. Now if we put a thermometer here, then we will see the temperature remain fixed at 0 degree centigrade. Now after some time, suppose after 1 minute, some part of the ice will melt. Okay, it starts melting and some of the ice will melt, and there will be a mixture of ice and water in the beaker after 1 minute. So few ice will be in this manner, and there will be some water, as the water will be there last the bottom. So some of the water is also there. At the same time, some ice cubes are also there. So at this point of time also, the temperature remains fixed at 0 degree centigrade. So this temperature will remain fixed at in this process, when all of the ice will melt, and we are getting the water. Okay, so the temperature of the water also will be 0 degree centigrade. Okay, the icy cool water, the water which we have got from the melted ice, the temperature of the water also will be 0 degree centigrade fixed. Okay, now if after all the ice melts to form the water, if we again apply heat on this, then only the temperature of this water going to increase. Okay, when all the process of interconversion of solid to liquid, that means the melting process gets over, then only the water can increase its temperature if we apply heat further. Okay, so this fixed temperature, as it's remain fixed, as during the change of the process the temperature is not getting changed, so this is called the melting point of this. This temperature is called melting point, and from that we can determine whether the substance which we are taking, that is pure or not. If the ice is not pure. If some other substance is mixed with the ice, then we will not get the melting point at 0 degree centigrade. Okay, so from this we can test the purity of the substance as well. For pure substance, the melting point will be fixed for each and every substance. Each and every pure substance, the melting point will be fixed. Next, we are going to discuss vaporization or evaporation. Vaporization or evaporation. So this is the process where we are going to see liquid state, the change of liquid state to gaseous state by applying heat. Okay, that means from water, if we see the state of change of state of water, then from water we can get water vapor. So this water itself can be converted to water vapor by because of heat of sunlight and all. Because of if we keep it in open, then from atmosphere water absorbs heat and it can convert to water vapor, but that will take some time. So this is called evaporation. But if we apply heat on water, if we directly heat water, if we apply heat from outside, then the process will be faster. And the extreme point of evaporation or extreme point of vaporization, that is called boiling, which we see boiling of water we can see, and in our everyday life we are doing that also. So this, when from outside we are heating water and water changes to water vapor, at that point of time this process is called boiling. So boiling is the extreme condition of vaporization or evaporation. Now, why this change takes place? As we have seen for melting, the same thing we are going to see for vaporization or evaporation also. So let us see the position of the particles in water. In liquid, the particles are there are some space in between the particles, and the particles are arranged in this manner. So these are the particles of water or liquid. And for water vapor, we know there are a lot of gap between the particles of vapor or gas. So suppose these are the particles. So when we are applying heat on water, the water particles, the molecules absorb heat. The same manner they absorb heat, it will get heated. All the particles get heated and their energy increases. Okay, their kinetic energy increases, and because of this high kinetic energy, because of the increased kinetic energy, their movement will increase and they will move in this manner in each in every possible direction they will move. And because of this motion, their intermolecular space between them will increase and they becomes water vapor, or they becomes the state of this water or liquid become gaseous. Okay, the state will change and the liquid become gas. So as in gaseous particles, there are a lot of space in between and they are far apart. So in this way the water changes to water vapor. Okay, as because of the heat which we are applying or they are absorbing from outside, their kinetic energy increases and their randomness increases and the movement of the particles increases. As a result, the gap between them, the intermolecular space between them increases and the state changes from liquid to gas. Okay, and at this point of time we are getting the boiling point. Boiling point is nothing but the temperature which will remain fixed during the process of boiling or evaporation. Okay, so the temperature related to this process is called boiling point. For pure water, the boiling point will be 100 degrees centigrade. Okay, so as we are applying heat here, and as we are applying heat, but the heat increases the intermolecular space. Heat increases the kinetic energy of water particles or the liquid particles, and the heat involves itself to do the changes in the state of matter, state of water. That's why the heat is not changing the temperature. The temperature will remain fixed at 100 degrees centigrade for pure water. So you will notice that if we heat some water in a pan, then at first we will not see the bubbles. If we put a thermometer inside this, then suppose in a pan we have taken some water, okay, and we are heating this. Okay, so this we have put on the gas burner, gas stove, and we are heating this. So at first we will not see the bubbles inside the water, and at this point we are putting the thermometer here and we can check the temperature of water. So slowly when we are applying heat, we are giving heat to this pan, and that means to the water, then slowly the temperature rises, and up to a fixed point, that means 100 degrees centigrade temperature, we can see the bubbles in this water. Okay, we can see the bubbles in this, and at that point of time we can see the liquid water changes to water vapor. Okay, that means the boiling process has been started and the temperature is remaining fixed at 100 degrees centigrade till the whole water changes to water vapor. Okay, till this process going on, the temperature will remain fixed at this 100 degrees centigrade temperature. Okay, provided the water which we have taken, that is pure. For pure water only we are going to get this temperature. Otherwise, if the water is not pure, then it will be little bit more or less. Okay, so, generally it becomes more than 100 degrees centigrade. So this is the boiling point, where during the boiling of water, during the boiling of any substance, any liquid, the temperature will remain fixed, and that heat which we are providing, that will engage itself to change the state of the liquid to gas. Okay, that's why it cannot increase the temperature, and the temperature remains fixed at a certain point. And here also we need to check it at normal atmospheric pressure. That means the pressure remains constant at normal atmospheric pressure. As pressure is also as I already told, that pressure is having a effect on this boiling point and all. So here we must need to keep the pressure constant. So here I am ending our today's class. Few more terms are there related to this, that we are going to discuss in our next class. Okay, till then be safe, keep studying, do your study properly, be safe, be careful. Okay, thank you, have a good day.